and welcome to the video. In this video, we are going to be looking at presenting a number as a product of its prime factors. What that means is we can take any number greater than 1 and we can split it to show that it can be made by multiplying other whole prime numbers. So what we're trying to find is a list of prime numbers that multiply together to give us the original number. This becomes very useful in GCSE maths when we're trying to work out things like highest common factor and lowest common multiple. Okay, so here's the process of presenting a number as a product of its prime factors. If we start with the number 60, we're going to take this number and divide it into two factors, or present it using two factors. So two numbers that multiply together to give us 60. I've used 2 and 30. You could have used 4 and 15. You could have used 10 and 6, and your factor tree, which is what we're producing here, would have looked slightly different, but your final answer will be the same. I have noted here that if you use the number 2 as one of your factors, if it is possible, it just makes the calculation a little bit easier. So over here, I've divided 60 into 2 and 30, and you'll notice that I've circled the 2. I've circled the 2 because it is a prime number. I haven't circled the 30 because it is not a prime number. Now I'm going to repeat that process. So with the number 30, I'm going to split it into two factors, and I would like one of the factors, if possible, to be a prime number. Again, I'm going to go with the number 2, just for ease. So I'm going to split that into 2 and 15. And again, I've circled the 2 because it is a prime number. The 15 has not been circled because it is not prime. Then I'm going to repeat the process again. I'm going to look at the 15 and split it into two factors. This time it's not even, so I can't use the number 2, but I can split it into the factors 3 and 5, because 3 times 5 gives me 15. Now I can't go any further because all the numbers I'm left with are circled. So this is going to be my answer. 2 times 2 times 3 times 5 is the answer to presenting 60 as a product of its prime factors. So here is my answer, 2 times 2 times 3 times 5. And I could also give my answer in index notation. All that means is if I've got two 2's, I can write it as 2 squared, just to look a little bit more mathematical. And this is my final answer. Just make sure you read the question, because sometimes the question will ask for the index notation answer or the index answer. Let's try another example. Okay, if I'm starting with the number 84, first thing I'm going to do is I'm going to split it into two factors. I'm going to use the number 2 because it's a little bit easier for calculating. So I'm going to split that into 2 and 42, and I've circled the 2 because it is a prime number. 42 is not prime. Then I'm going to go ahead and split 42 into 2 and 21, and I've circled the 2 because it is a prime number. Remember, when you've used the number 84 and 42, you might have taken out different factor pairs, and that's fine. It just means your factor tree will look different to mine, but your final answer will always be exactly the same. Now I'm dealing with the number 21. I can't use the number 2, but I can split it into the factors 3 and 7, because 3 times 7 gives me 21. So now I'm left with 2 times 2 times 3 times 7, which would give me 84. So to present 84 as a product of its prime factors, my answer would be 2 times 2 times 3 times 7, or 2 squared times 3 times 7. Okay, one more example from me. So this time I'm going to split the number 75 into a product of its prime factors. This time when I first look at the number, it is not even, so I can't use 2 as one of the factors. The next easiest factor to use, in my opinion, would be the number 5, because the 5 times table is generally considered to be one of the easier times table. So I'm going to remove the number 5 as a factor. So two numbers that multiply to give me 75 when one of the numbers is a prime number, 5 times 15, and I've circled the 5 because it is a prime number. Then I continue the process with the number 15. I'm going to split that into 3 and 5. Both of those numbers are prime numbers, so they both get circled. So this time the factor tree is a bit smaller, and the factor tree is quite brief, but I followed the method and my answer is 5 times 3 times 5. When I present my answer, you can see I wrote it as 3 times 5 times 5. So I've just given my answer in numerical order. Again, I could also present it in index notation. Because I've got two fives here becomes 5 squared. So 75 presented as a product of its prime factors is 3 times 5 squared. Okay, so here are two questions for you to have a go at. For each of these numbers, the number 100 and the number 52, could you produce a full factor tree, showing me the full method, circling your prime numbers, and then giving me your answer as a product of its prime factors, and also present that answer in index form if appropriate. Okay, could you pause the video now, and then when you're ready to see the answers, if you could unpause the video. Okay, welcome back. Let's have a look at what your factor tree should look like for the number 100. Here is my answer. So we've got the number 100. I've split it into the factors 2 and 50. I've circled the 2. Then I've taken the number 50, split it into 2 and 25, circled the 2, and then I've split the number 25 into 5 and 5 to give me my final answer of 2 squared times 5 squared. Again, you may have approached this in a different way. You may have split this into the factors of 10 and 10, or 4 and 25, and it just means that your factor tree would take a different shape, but your answer would have to be the same as mine for full marks. For the number 52, our factor tree looks like this, so it's a bit shorter this time. I've split it into the factors 2 and 26, and I've circled the 2, and then I've split the 26 into 2 and 13, 13 of course being a prime number, leaving me with the answer 2 squared times 13. Very well done if you got both of those correct. Okay, so this is your next task. Again, if you could pause the video at this point, for each of these numbers, could you produce a full factor tree and present each number as a product of its prime factors? You will see I want each answer given in index notation if possible. Okay, could you pause the video now and have a go at all 6 questions? Okay, welcome back to the video. I'm just going to show you my answers. So my answers for each question in index notation look like this. You will notice for number 2 in the red section that no numbers were duplicated. So we didn't have 2 2s or 2 5s or 2 11s. Therefore, there was no index notation version of this answer. If you could mark up your answers, just making sure that they correspond with the answers on the screen now. Very well done if you're getting all 6 correct. Okay, so this is your next task. On the screen, I have placed 10 numbers. and I've placed 10 prime factorizations. For each of the numbers, I would like you to match it up, pair it up to the prime factorization that represents that number. You can approach this task in any way you want. You may want to use factor trees, or you may be able to pair them up in another way. Okay, could you pause the video at this point and go ahead and match up all 10 questions? Welcome back to the video. Very well done if you were able to match up all 10. I will just show you the correct matching so you can go ahead and mark your work. So these are the correct matchings. I've just color coordinated each one. Hopefully you were able to pair them up. You could have used prime factor trees to get your answer. You could have also used your understanding of what prime factorization is. For example, if we look at this number here, what that actually means is 2 times 2 times 3 is going to equal one of the numbers on the screen. So 2 times 2 is 4, times 3 is 12, so that would correspond to here. Similar if we picked this one here, 2 cubed is 8, times by 5 is 40, matching us up here. So the prime factor trees is a great way to approach this. It gives us some very good practice on how to present a prime factor tree, and we will be asked to do that in a lot of our exams and schoolwork. But you could have also used your understanding of what prime factorization is to come up with your answer. Very well done if you were able to match those up. Okay, so now we know how to use prime factor trees to present numbers as their prime factors. We are often asked in GCSE Maths to use those prime factor trees to find out the highest common factor of two numbers or the lowest common multiple of two numbers. So I'm just going to show how we would approach that sort of question. So if we've got the number 84 and the number 120, I'm just going to present them as a product of their prime factors. So there we go. You can see that 84 would be 2 squared times 3 times 7, and 120 would be 2 cubed times 3 times 5. I've just put a list of the first few prime numbers down the side just to jog your memory as we're talking through this process. Okay, so now I've got each of those numbers. How can I use those answers to find the highest common factor or the lowest common multiple? Okay, we're going to use a process of a Venn diagram to get those answers. Okay, so this is what my answer or my working out is going to look like. Here we go. So you can see I've drawn a Venn diagram, this circle representing 84 and this circle representing 120. Then I've wrote out my full prime factors, so I haven't used the indexed notation version. And every number that appears in both lists goes into this intersection. So what I mean by that is there's a 2 which crosses off with a 2, so I put a 2 in the intersection. There's a 2 that pairs up with this 2, so there's a pair that goes into the intersection. This 2 does not have a pair over here, but this 3 pairs up with this 3 and goes into the intersection. And then all the numbers that I haven't crossed off, they go into the circle as well. So the 7 here goes into the 84 circle, and the 2 and the 5 go into the 120 circle. So you can see how I've used these prime factors and placed them into the Venn diagram. This is going to help me find the highest common factor and the lowest common multiple. Okay, So using this Venn diagram, I'm going to find the highest common factor. Remember, the highest common factor is the biggest number that goes into both 84 and 120. The biggest number that 84 and 120 can be divided by. Once we've set up our Venn diagram, it's very easy to find the highest common factor. We take the numbers that are in the intersection and we multiply them together. So 2 times 2 times 3 gives me 12. So the highest common factor of 84 and 120 is 12. The biggest number that 84 and 120 can be divided by is 12. To find the lowest common multiple, and remember the lowest common multiple is the lowest number that appears in both the 84 times table and the 120 times table. So even though it's got the word lowest in, we're looking for a number that is higher than 84 and 120. To find that from the Venn diagram, it's a little bit more complex, but not too difficult. We multiply every number that we can see. So not just the intersection, we're also going to multiply the numbers that land in the separate circles. So the calculation we're going to do is 2 times 2 times 3 times 7 times 2 times 5. So that's going to tell me that the lowest common multiple of 84 and 120 is 840. The lowest number that appears in the 84 times table as well as the 120 times table is 840. Okay, so here's a question for you to have a go at. I would like you to pause the video at this point. For each of the numbers, 180 and 68, I'd like you to present them as their prime factor. So I would like you to show me the prime factorization of both numbers. I would then like you to use a Venn diagram in order to find out the highest common factor and the lowest common multiple of these two numbers. Once you have unpaused the video, I will show you my full working out, and hopefully after this second example, you've got a good understanding of how to find the HCF and the LCM of two numbers. Okay, could you pause the video at this point and have a go at this question? Okay, I'm just going to go ahead and show you my solution, and then I'll talk you through how I came up with my answers. Hopefully your solution should look something like this. So for the prime factor decomposition of the number 180, we're left with 2 times 2 times 3 times 3 times 5. And for the number 68, we're left with 2 times 2 times 17. 17, of course, being a prime number, even though it's a little bit larger than the numbers we've been dealing with so far. So then what I'm going to do is I'm going to place these values into a Venn diagram. I'm going to place numbers into the intersection if they pair up and appear in both lists. So this 2 pairs up with this 2. Therefore, I place the 2 in the intersection. And the only other thing that pairs up is the next 2. Again, that gets placed in the intersection. Numbers I'm left with here, 3, 3, and 5, get placed in this circle, because that is the circle represented by 180. And the number 17 gets placed in the circle represented by the 68. So now I've placed the numbers into the Venn diagram, I can go ahead and answer the questions. To find the HCF, the highest common factor of the numbers 180 and 68, I look at my intersection and I multiply the numbers that are contained within the intersection. So in this question, it's simply 2 times 2, giving me a highest common factor of 4. The highest number that is a factor of both 180 and 68 is the number 4. To find the lowest common multiple, the LCM of the numbers 180 and 68, I need to go ahead and multiply all the numbers that I can see in the Venn diagram. So the calculation I'm going to do is 3 times 3 times 5 times 2 times 2 times 17, which tells me that the lowest common multiple is 3060. So 3060 is the lowest number that appears in both the 180 and the 68 times table. Okay, there's another question for you to have a go at here. Again, could you answer this question in the same way we did the previous example? If you could prime factorize both of these numbers, draw out a Venn diagram and use that Venn diagram to find your highest common factor and lowest common multiple. Could you pause the video now, please? Okay, welcome back to the video. Let's have a look at my solution. My solution looks like this. So you can see my prime factorization. You can see that the numbers that pair up and end up in the intersection are actually 5 number 2s. When I multiply them together, it gives me the highest common factor, HCF of 32. For my lowest common multiple, I'm also multiplying all the numbers in the intersection by 5, 2, and 3 to give me a lowest common multiple of 960. Very well done if you were able to answer this full question. We'll be looking at about 5 or 6 marks in a test or a GCSE exam, because there'll be marks for your prime factorization, your prime factor trees. There'll be marks for your use of a Venn diagram, and of course there will be further marks for your HCF and LCM. Very well done. Okay, I have placed 3 additional questions on the screen, very similar to the examples we've just talked through on the previous slides. The only difference being that the first 2 questions only ask for the highest common factor, and the third question only asks for the lowest common multiple. Could you pause the video now, showing me your full working out? Could you answer these 3 questions? Welcome back to the video. I have a quick look at my solutions. My answers for each of these 3 look like this. Very well done if you were able to get these 3 answers by your use of prime factorization, your understanding of Venn diagrams, and then leading you to the HCF or the LCM. Just at this point, I'll point out, try not to get confused between highest common factor and lowest common multiple. Even though highest common factor has the word highest in it, we are usually looking for a number which is a lot smaller than the numbers in the question. And even though the term lowest common multiple has the word lowest in it, we are often looking for a number that is a lot higher than the numbers in the question. So just make sure you're not getting confused with the terminology. Okay, one additional task here, a bit of an extension task, some IGCSE questions which have came from past papers. If you would like to pause the video here, and when you unpause the video, I'll show you my full working and all of my solutions. Could you have a go at the questions on the screen now? Okay, welcome back to the video. I'll just go ahead and show you my solutions. My solutions look something like this. So you can see my use of prime factor trees. You can see my use of Venn diagrams. Basically showing you my full working out, how I've ended up with my highlighted answer. Very well done if you were able to go ahead and answer these questions. Just to briefly talk about a couple of the questions. This one here is asking for a lowest common multiple of the numbers 20, 30 and 45. And because these were quite simple numbers, and in my head I assumed the lowest common multiple wouldn't be too far into their times tables, rather than going ahead and using the Venn diagram method, I simply just wrote out the 20 times table, the 30 times table, and the 45 times table until I hit a number that appeared in all lists. So this method is useful, but only if the lowest common multiple is going to be achievable quite early. For the last question here, you can approach this question by finding the prime factorization of 140. And because we knew the HCF was 20, I knew 2, 2, and 5 had to be present in the intersection, leaving the 7 over here. Therefore, I had an unknown value in this box here, which when I created this little equation, making it equal to 420 for all terms multiplied together, being the lowest common multiple. When I calculated the value of y, it became 3. So I knew this value in the second circle was 3. This unknown value would be 3, which then led me to finding the value of x, which was the value of the number associated with this full circle here. A very tricky question, but very well done if you were able to find the value of x being 60. Very well done if you were able to work through a lot of the questions in that video. That would show a good understanding of prime factor trees, highest common factor, and finding the lowest common multiple.